Today we're talking about solving systems of equations by graphing, so make sure you pause the video and take a second to write down this title. This is the third lesson that we're doing, so make sure you have L3 next to the title. Okay, so what we're talking about are systems of equations. There are two equations, like for example y equals 4x and y equals 4x plus 2, that together have a certain number of points, but one ordered pair, or the point of intersection, as we like to call it, is a solution for both systems because it's going to satisfy both equations. Okay, so let's look at what I mean by that. If we wanted to solve this system of equations where y equals a negative 2x minus 3 and y equals 2x plus 5, if we wanted to graph it, we can graph both these equations by plotting the y-intercepts and then the slope, and finding that the solution to both equations would be at the point of intersection at negative 2 comma 1. I kind of made that a little too big so you couldn't see the 1 there. So at negative 2 comma 1, what that means is at that point it fits into this equation and into this equation. I can also check my work by saying, okay, if I plug back into the equation as an input, remember this is your input, your x, plug it in for x, and if I get my output as 1, then I know that my answer is correct. So in this particular equation, negative 2 times negative 2 is positive 4, excuse me. And then if I take 3 away, I'm left with 1, which equals 1. In this equation, if I take negative 2 times 2, I get negative 4. If I add 5, I get 1, which equals, again, the output. Okay, so what I want you to try to do is I want you to first, using graph paper, go ahead and graph both this point and this equation. This equation and this equation. Find the point in which they intersect, okay? Go ahead and try that. Pause the video. I'll be back in just a second to show you the answers. Okay, so if you graph this particular equation, you would see that when x minus 1, the negative 1 is your b, and then your rising 1, running 1, rising 1, running 1, and so on and so forth, okay? For this particular equation, your b, or your y-intercept, is negative 2. So at negative 2, you are going to rise 2 and run 2. Rise 2 and run 1. Rise 2, run 1. Rise 2, run 1. Okay, so where do they both intersect? Take a look right here. The point of intersection is at 1 as x and 0 at y. So the point of intersection is 1 comma 0. Okay, so over here, if I graph y equals 4x, the b, or the y-intercept, is at 0. So I'm rising 4, running 1, and I'm falling 4, going back 1. Because remember, you can also do slope negative on top and on bottom because that would still equal 4 over 1. For this particular equation, my y-intercept is at 3, so I'm rising 1, running 1, rising 1, running 1. I could also do fall 1 and go back 1 because that equals 1 over 1, or just 1. So our point of intersection is right here, where 1 is x and 4 is y. Okay, so solving systems of equations continued. Let's look at this one. Gregory's Motorsports has motorcycles that have 2 wheels and ATVs that have 4 wheels in stock. The store has a total of 45 vehicles that together have 130 wheels. They want us to first write the systems of equation that represents the situation. Okay, so for example, let y represent the motorcycles and x represent the ATVs. Remember, the number of motorcycles and ATVs is 45. So if we were adding the motorcycles with the ATVs, we get 45. The number of wheels equals 130. So if we took and we multiplied the number of wheels on the motorcycles, so 2 times the motorcycles, plus 4 times the ATVs, we would get 130. Okay? Oops, I didn't mean to move my hint. Okay, so we've got our systems of equations. Now what can we do? Well, Because our systems of equations aren't in slope-intercept form, we first have to make them into slope-intercept form. So we change the order, remember? So we subtract x on both sides, and now we have y equals a negative x plus 45. Over here, we would have to get rid of the 4x by subtracting 4x on both sides, so that's why it's a negative 4x plus 130, and then dividing each piece by 2, so that way we can get only one y. So y equals a negative 2x plus 65. So that's our slope-intercept form. We've done it. Oops, sorry about that. Okay, so now what we need to do is we need to graph them. Okay, so I'm going to take this one and I'm going to graph it, and I'm going to take this one and I'm going to graph it. Okay, when I graph, notice that the point of intersection is at 20, 25, right? This one was at, the y-intercept was at 45, and then it fell back one every time. Okay, it was a negative slope. Same with this one, it's going to have a negative slope as well. Okay, so when I graph these, they have a point of intersection at 20, 25. So they intersect at 20, 25, so the solution is that 20, 25 means that we have 20 ATVs and 45 motorcycles, because remember the ATVs and the motorcycles. Okay, so to check this, we can plug in 20 for x and 25 for y, and we get 45. We can plug in 25 for our motorcycles, which was 2 times 25, and 20 for our ATVs, which was 4 times 20, and that solution works for both equations. Okay, so now I want you to try this one. Creative Crafts gives scrapbooking lessons for $15 per hour plus $10 supply charge. Scrapbook Incorporated gives lessons for $20 per hour with no additional charges. Write and solve a system of equations that represents the situation. So you're writing two equations, you're going to graph it, and you're going to find the point that is a solution to both equations. Go ahead and try that right now. I'll be back in just a second to show you the answers, so make sure you pause the video. Okay, so let's take a look at this. If we graph these, they are crossing at 2 hours for $40. So what that means is that if you take a lesson for 2 hours, both stores are going to be completely equal. Okay, so the way that you would write your first equation was 15x plus 10 equaling y, and 20x equals y. So after you graphed, we see that this would be our point of intersection. Okay, so let's talk about some special cases. At the top of the page, write solutions, or wherever you are next, write solutions for me. If you solve a systems of equations and both of them do not cross one another, meaning they are parallel. If they are parallel, that means they have no solution. Okay, so once you've graphed, you can see that if their slope is exactly the same, but their intercept is different, their y-intercept is different, they are going to have a no solution. Okay? For this one, if they have the same equation, meaning, okay, this one was put into standard form, or excuse me, into slope-intercept form. This one was in standard form. If I add 3 to both sides, I get the exact same equation. So if they have the same slope and the same y-intercept, then they're the same line, which means every single point on that line will work. So infinitely many solutions. Okay, so 2 things that you need to have in your notebook are no solution and infinitely many solutions. Okay, for this, so you can have one solution, like we saw up here, like what we saw up here, right, where there's one intersection. You could have them not intersecting at all, no solution, or you could have infinitely many solutions. Okay, I want you at the bottom of your page, please, write for me, graphing takes a lot of time. Okay, write that in your notebook and bubble it in. Please do not tell anyone else that you wrote this in your notebook except me, okay? I will be looking for this in your notes. All right, thanks. See you next time.